Hello, this is Sal. In today's video, we will be configuring Advanced EIGRP. EIGRP, Advanced Interior Gateway Routing Protocol, is an advanced distance vector routing protocol that is used on a computer network for automating routing decisions and configuration. The protocol was designed by Cisco Systems as a proprietary protocol available only on Cisco routers. EIGRP has advanced features to allow changes related to summarizations, default route propagation, bandwidth utilization, metrics, and security. In today's lab, we will configure automatic and manual summarization for EIGRP, configure EIGRP route propagation, fine-tune EIGRP metrics, and use MD5 authentication to secure EIGRP routing information. I hope my videos are helpful for those who are seeking to be certified for the CCNA and the CCNA security exams. If you like my videos, please subscribe to my channel and recommend it to your friends, and share it and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will find two files, one for the packet tracer source file and the documents to walk you through step by step until you finally will be able to verify the configurations you did during this lab. Now I will start by configuring the router's interfaces, but will not do the loopbacks at this time. The loopbacks here, as you can see on the blue, I'll not configure them now, just I'll start with the routers. And some of the features are not supported on packet tracer, but I will mention them and go with you over them. But any command that is not supported by packet tracer, I will point them out to you. Now starting with router 1, enable, I'll give it the host name as router 1. Now I will, for the line console, 0, logging synchronous. Here now with the interface for router 1, this interface, gig 00, then the serial 001 and serial 00. These are directly connected to router 1. For router 2, we have the same gig 00 here, and the two interfaces, these are directly connected to router 2, and the same here with router 3. So on router 1, interface of gig 00, IP address of 192.168.1.1 with /24 subnet mask, and open the port with no shut. The interface of serial 000, the IP address of 10.1.1.1 with /30 subnet mask 252, and open the port or enable the port. And the other interface of serial 001, the interface connecting router 1 with router 3 here on this side, 33 IP address of 10.3.3.2 with /30 subnet mask, and open the port with no shut. So now I will move to router 2, this guy here. Enable, configure terminal, the host name, router 2, the interface of gig 00, IP address of 192.168.1.2.1 with /24 subnet mask, and enable the port with no shut. The interface facing router 1 on serial 000, IP address of 10.1.1.2 with /30 subnet mask, no shut. And the interface facing router 3, the IP address of 10.2.2.1 with /30 subnet mask, and open the port with no shut. I'll do the same here. Exit logging synchronous. Our first line console 0 logging synchronous. Now on router 3. Give the host name, configure terminal, host name of router 3, line console 0, logging synchronous, interface of gig 00, IP address of 192.168.3.1/24 subnet mask. This guy here on router 3, and enable the port with no shut. IP interface of serial 001, interface facing router 2, IP address of 10.2.2.2/30 subnet mask. Enable the port, and the interface facing router 1 on serial 00, this guy here, 0, IP address of 10.3.3.1/30 subnet mask, and enable the port with no shut. So as we can see here, everything is configured, and we have the green here, which means they are connected directly, the networks directly connected to the routers. Next, I will configure basic EIGRP for the network, and I will set the bandwidth for the serial interfaces. On router 1, I will configure EIGRP routing with an autonomous system ID of 1 for all directly connected networks. The directly connected networks for router 1 is this network 192.168.1.0/24, and this network 10.1.1.0/30, and this network here 10.3.3.0/30 facing router 3. So back to router 1. Router EIGRP autonomous system ID of 1. Now the directly connected network of 192.168.1.0 with the inverse subnet mask of this, and the other network of 10.1.1.0 with /30 subnet mask, and the other network facing router 3 of 10.3.3.0 with the inverse subnet mask of this. Next, I will disable the transmission of EIGRP hello packet for the LAN interface on router 1, which is this interface here. So simply typing the command passive interface on gig 00. Next, I will configure the bandwidth for serial 00 to 1024 kilobit per second, and the bandwidth for the serial 0/0/1 to 64, as this guy here on this interface, and for this interface of 64 kilobit per second. So now go back to router 1, and on the interface of serial 000, bandwidth 1024, and for the other interface facing serial router 3, the bandwidth of 64. Next, on router 2, we are done here for now on router 1. So now on router 2, I'll configure EIGRP routing with an autonomous system ID of 1 for all networks, disable the transmission of EIGRP hello packets for the LAN interface, and configure the bandwidth for the serial 000 to 1024 kilobit per second. I'll configure this guy here. So now on router 2, exit here, router EIGRP, autonomous system ID of 1, the directly connected networks of 192.168.2.0 with this inverse subnet mask, and the other network 10.1.1.0 with /30 inverse subnet mask of this, and the other network of 10.2.2.0, the inverse subnet mask of 30 of this network. Now, as passive interface on gig 00, and exit from here. And now for the, I'll configure the bandwidth. Sorry about that. I will configure the interface here for 1024. So back to interface serial 000, bandwidth of 1024. So now we are done with this. Now, as you can see, the serial went down and then went back up. Now, on router 3, I will configure EIGRP routing with an autonomous system ID of 1 for all directly connected networks, disable the transmission of EIGRP hello packet for the LAN interface for this network, and configure the bandwidth for the serial 00 to 64 kilobit per second. I'll configure this interface here for 64 kilobit per second. So now on router 3, exit, router EIGRP, autonomous system ID of 1, the directly connected networks of 192.168.3.0 with this inverse subnet mask, the other network of 10.2.2.0.3, and the third network facing router 1 of 10.3.3.0. And as you can see, it is, we have new adjacencies with the neighbors. Now I will configure the passive interface, router EIGRP1, passive interface on the gig 00, exit from here. Now on the interface of serial 00, bandwidth, we will configure it, as we said, of 64 kilobit per second. Now, it's time to test connectivity, as all PCs now should be able to ping one another. So let's go for PC A here and ping the PC B. Click on desktop and on command prompt, ping 192.168.2.3. It should be successful. And also from PCA, I'll ping PCC, ping 192.168.3.3, and also this should be successful. Here we go. Next, I will configure summarization for EIGRP. I will add loopback interfaces to router 1. And then I will enable EIGRP automatic summarization on router 1 and observe the effect on the routing table on router 2. Also, I will add the loopback interfaces on router 3. Before adding the loopback interfaces, I will issue the command show IP protocol on router 1. So let us run this command here. Show IP protocols. As you can see here, automatic summarization is showing us it's disabled. And the default status automatic summarization in EIGRP. Now, I will configure the loopback addresses on router 1. This is router 1, and these are the loopback addresses here on router 1. So on router 1, configure terminal interface. I'll move this a little bit. For loopback 1, IP address of 192.168.11.1 with /30 subnet mask 252, and now the interface of loopback 5, IP address of 192.168.11.5 with the /30 subnet mask, and the interface of loopback 9, IP address of 192.168.11.9 with /30 subnet mask. And now for the loopback 13, interface loopback 13, IP address of 192.168.11.13 with /30 subnet mask. Now we are done configuring the loopbacks on router 1. Next, I will add the appropriate statement to the EIGRP process on router 1. So now on router 1, back to router 1, exit here, router EIGRP with autonomous ID of 1. Now let's see the directly connected networks, or type the command do show IP route connected. As you can see here, the network of 10.1.1.0 is directly connected on this interface, and the network here, the 10.3.3.0, is directly connected on the interface of serial 001, and we have the loopbacks, as you can see here, of 192.168.1.0, which is this LAN here, and we have the loopback of the 192.168.11.0, which is this IP address for this loopback network here, and the 11.4, which we have the interface of this interface of 192.168.11.5.30. Now, I will do the loopback network here, network of 192.168.11.0 with /30 inverse subnet mask, and the other network of .4 /30 subnet mask, and the network of .8 /30 inverse subnet mask, and the network of 12 with /30 inverse subnet mask. Next, I will issue this command on router. Now we did this work on router 1. Now I will go to router 2 and issue this command. Now you will notice how are the loopback networks are represented. And from here, show IP route EIGRP. Notice here, this network D, this is for EIGRP. The loopback, or let us start from here, from the top. These are all subnetted, 5 subnets and 2 masks. The network of 10.3.3.0 is connected via this interface and this interface. This is how it can be reached. And look at the loopbacks here, all connected via this serial interface. all subnetworks, including the loopback networks, are listed in the routing table output. Now, on router 1, I will issue the auto summary command. Now, notice this for now. This is on router 2. Now, on router 1, here I will issue this command, the auto summary, so we can summarize all the networks. On router 1, I'll end from here, configure terminal, start from the beginning, router, EIGRP 1, simply just type auto summary and hit enter. Now, let us go back to router 2 and run the show command to see if the routing table changed. This is the table now. I will run the command again, show IP route EIGRP. Now notice for the loopbacks here. Now when I hit enter for this command, show IP route EIGRP, and we have for this network, this is on router 1, and this is on router 2, and this on router 3, and these are all the loopbacks. As you can see, they are via 10.1.1.1 and on serial 00. Here we have them all, now all of them here, and they were all summarized with this IP address. Now, as I said, after we run this command, you notice that the 192.168.11.0 network are summarized at their classful boundary, all of them at their classful boundary. Next, I will configure a manual summarization for EIGRP. I will configure the loopback addresses on router 3. So now let's do this manually here on router 3. I will start from the beginning end here. So on router 3, configure terminal, the global configuration, interface for loopback 1, IP address of, I'll show them to you now, 192.168.33.1, the 33.5, the 33.9, the 33.13. So now let's start with the first one. IP address of 192.168.33.1 with /30 subnet mask, and the loopback 5 IP address of 192.168.33.5 with /30 subnet mask, and the interface loopback 9 IP address of 192.168.33.9 with /30 subnet mask, and the interface loopback 13 with the IP address of 192.168.33.13 with /30 subnet mask. Next, I will add the appropriate network statements to the EIGRP process on router 3. So I'll exit from here. Router EIGRP process ID 1. Now let me run this command. Do show IP route connected. Let's see what we have here. So we have the network of 10.2.2.0. This network here is connected directly via this serial interface, and the other network here of 10.3.3.0 directly connected via this interface. And we have this network, this LAN here of 192.168.33.1 3.0 is connected via the gig 00, and here we have the loopbacks on this router. So now I will, for the network of the loopback network 192.168.3 the 33.0 with the inverse subnet mask. The second network of which is this network here. Sorry, need to move it this way. That 4 with the inverse subnet mask of 30 and after 3 of 8 and the last one of 12. So we configured EIGRP for the loopbacks. Now let us move to router 2 and issue the show command here. So we'll type the command show IP route EIGRP. As you can see here, for this network on router 1, the LAN on router 1, the LAN on router 2, the LAN on router 3, and these are configured on router 1, the loopbacks, and now we have the loopbacks here on router 3. Now, as you noticed, the loopback networks from router 3 represented in the output. All subnetworks, including the loopback networks, are listed in the routing table output. Now I will determine the summary EIGRP route for the loopback addresses on router 3. If you go back to the walkthrough documents, we have the first one, the first network of 192.168.33.0/30, and the second network, this one here, and the third loopback, and the fourth. And when we take the last octet, the first 4 to the right octets are all gonna be 0, and the other 4 bits on the first octet to the right are all zeros. So we will come up with the IP address when we summarize everything, because the 0 bit with the 0, 0, 0, it will give us 0. But if one bit is turned on and the second one is off, it will give us, it will be off, so it is 0, and it is all explained on the walkthrough, and this will show you how to do this. So the conclusion, we will come up with an IP address of 192.168.33.0/28, because in the last octet here, you know, on the networks, you know, because we take 4 bits from it, so we have 24 bits here plus 4, which give us 24 plus 4, which is 28. So the IP address, we will summarize these all 4 IP addresses for these loopbacks to 192.168.33.0/28. Next, for the serial interfaces on router 3, I will issue the command IP summary address EIGRP1. It's the network address and the subnet mask to manually summarize the network. So now on router 3. So for these all networks, the loopbacks on router 3, so the IP address, we summarize all of these IP address 192.168.33.0/28. So now here exit, for the interface of serial 000 IP, the command goes like this: IP summary address EIGRP autonomous system 1 of 192.168.33.0 with a subnet mask of 255.255.255.240. Now for the other interface of serial 001 are the same. IP summary address EIGRP autonomous system ID of 192.168.33.0. This is what we summarize all the loopback IP addresses to this one and hit enter. As you can see, the adjacency is up. Now let's go back to router 2 and see what changes happen on the routing table. So this is the routing table on router 2. As you can see, we went over it a few minutes ago. So let's issue the command again. Show IP route EIGRP. Enter. And as you can see here, it all for the loopbacks on router 3, it summarizes to this IP address 192.168.33.0/28. And these are the loopbacks on router 1, 192.168.11.0/24. Now, the manual summarization for the loopback on router 3, the 192.168.33.0 networks are summarized manually with the subnet mask of /28. Next, I will configure and propagate a default static route on router 2. I will configure a default static route and propagate the route to all other routers. So here we are still on router 2, which is this guy here. Configure terminal. Interface loopback 1. The IP address of 192.168.22.1 with /30 subnet mask, which is this loopback here, as you can see for on router 2. Next, I will configure the default static route with an exit interface of loopback 1. So the command goes like this: IP route for any network with this subnet mask and the exit interface of loopback 1. And don't worry about this warning or this what we can see here. I will use the redistribute static command within the EIGRP process to propagate the default static route to other participating routers. So here, still on router 2, router EIGRP of autonomous system ID of 1, redistribute static. Now on router 2, I will use the command show IP protocol to verify the static route is being distributed. Show IP protocols. Oh, sorry about that. Enter here. Redistributing EIGRP with autonomous ID 1 is static on router 2. I'll go back. Here we go. So we made sure that it is. The static route is being distributed. what does redistribute static mean when we run it here on router 2? It is the process of advertising the routes learned by a routing protocol to another routing another routing protocol. So once again, the redistribute static mean it is the process of advertising the routes learned by a routing protocol, which is in this case EIGRP, to another routing protocol. When a static route to a destination is available pointing to an interface rather than a next hop address, it can be redistributed into EIGRP either by issuing the redistribute static command or configuring a network command for the network in the static route. Next, we will work on router 1 and issue the command show IP EIGRP route pipe include the static route to view statements specific to the default route. How is the static default route represented in the output? What is the administrative distance, which is stands for AD, for the propagated route? So on router 1, I'll run this command, enable show IP route EIGRP pipe include static route, enter. As you can see here, the administrative distance is 170, as you can see here, as it is an external EIGRP route. Next, we'll fine-tune EIGRP. I will configure the percentage of bandwidth that can be used by EIGRP interface and change the hello interval and hold timers to EIGRP interface. I will configure bandwidth utilization for EIGRP. I will configure the serial link between router 1 and router 2 to allow only 75% of the link bandwidth for EIGRP traffic. So now the commands I'm going to be running here, they are not supported by Packet Tracer, but I'll show you how it is configured or how to run it. So here on router 1, the command goes like this: configure terminal on the interface of serial 00. You type the command as follows: IP bandwidth percent EIGRP autonomous system ID of 1, and we want to use only 75% of the bandwidth. If we hit enter, it is not supported, but this is how the command, from the bandwidth, as you can see here of this, we want to use only 75%. This is how you run the command. And also on router 2, you do the same. On the interface here of serial 00, we want to use only, you use only 75% of the bandwidth here. You need to use the same here. And the command goes like this. But unfortunately, it is not supported by Packet Tracer. So interface of serial 000, to type the command as follows: IP bandwidth percent of EIGRP autonomous ID of 1. We want to use only 75% of the bandwidth, and sorry, it is not supported by Packet Tracer. But I'm showing you how you configure it, how you run the command. So now I will configure the serial link between router 1 and router 3 to allow 40% of the links bandwidth for EIGRP traffic, and once again, it is not supported. The way how to do it, for example, between router 3 and router 2 or router 3 and router 1, is type the command like this: IP bandwidth percent EIGRP with the autonomous system, and we want to use only 40%, but unfortunately it's not supported on packet tracer. But just to have an idea. So now on router 2, let me run this command, which is also unfortunately is not supported by packet tracer. The command is show IP EIGRP interface detail, and also this is not supported. Exit show IP EIGRP interface detail is not supported, but this one here is supported without the word detail at the end of the command. And here is showing us for the serial 001 appears only 1, and this is what the output without the word, the interfaces, you know, when you run this command, without the detail. So now I will configure by default, the hello intervals is 5 seconds and the hold time is 15. So the hello intervals, they are 5 seconds and the hold timer is 15, which is 3 times 5, 15. I will configure the serial 000 and the serial 001 interfaces on router 1 to use the hello intervals of 60 seconds and the hold time 60, 3 times 60 is 180 seconds for the hold time. But unfortunately, it's also not supported by packet tracer, but I will run the commands just to show you. So here on router 1, exit for the interface of serial 0, the commands goes like this: IP hello interval EIGRP 1 60 seconds, enter. But for the hold time, IP hold time EIGRP autonomous system ID of 1, which is 180. This is not supported, and as you can see, the interface went down. So in this case, we want to bring it back up to 5. So both of them should go together for the hello interval and for the hold time. And as I said, the hello intervals is 5 seconds and the hold time is 15. Here we want to configure which packet tracer support this command, the hello intervals for the interface. We want to configure it of 60, which we need to configure the hello intervals of the hold time of 180, which is not supported by packet tracer. So I had to reimburse the command back to 5 seconds, which is this is by default. Unfortunately, these commands are not supported on packet tracer. Now let's I'll configure EIGRP authentication. I will create an authentication key on all routers and configure router interfaces to use MD5 authentication for EIGRP message authentication. So on router 1, I will use the keychain name command in global configuration mode to create a keychain with the label EIGRP keys. So here on router 1, the command goes like this: exit here key chain EIGRP keys key 1. The key string will use Cisco exit and exit here. So I'll do the same on router 2 and router 3. So we did this on router 1. So now to router 2, configure terminal key chain EIGRP keys key 1. Key string, as we said, we use Cisco exit exit to exit twice. We did it on router 1 and router 2. Now on router 3, enable configure terminal key chain EIGRP keys key 1, and the key string as we use them on router 1 and router 2 of Cisco, and I'll exit twice here. Next, I will run the command show keychain, but this command, unfortunately, again, is not supported by packet tracer. Show key chain. It's not supported. I'm sorry about that. Now let's configure EIGRP link authentication on router 1 with the following commands. So we configure the keychain and the key string of Cisco. So back to router 1 here. So as for the interface of serial 000 IP authentication keychain, the routing protocol of EIGRP with autonomous ID of 1, EIGRP keys, IP authentication mode, EIGRP 1 MD5. Now for the other interface we configured serial 000. Now this interface here, serial 001 IP authentication keychain EIGRP autonomous ID of 1, EIGRP keys, IP authentication mode, EIGRP 1 MD5. Now the serial went down, we need to configure the other interfaces. So I'll do the same to activate EIGRP authentication on the serial interfaces on router 2 and router 3. So we are done now, but the interfaces went down, so we want to bring them up so they will be on the same authentication mode. So we are done with router 1. Now on router 2, the interface of serial 000 IP authentication keychain of EIGRP with autonomous ID of 1, EIGRP keys, IP authentication mode, EIGRP 1 MD5. The other interface of serial 01 IP authentication keychain EIGRP 1 EIGRP keys, IP authentication mode, EIGRP 1 MD5. I'll do the same on router 3. Configure terminal, interface serial 000, IP authentication keychain EIGRP 1 EIGRP EIGRP keys, IP authentication mode EIGRP 1 MD5. The other interface, IP authentication keychain EIGRP 1 EIGRP keys, IP authentication mode EIGRP autonomous system ID of 1 MD5. And as you can see, when we configured them with the same authentication MD5, the interfaces came back up. Now on router 2, I will use the show command, show IP, but unfortunately it's not supported, but we need this command, but it's not supported on packet tracer. The command we need to run here to know what we did so far is show IP EIGRP, and from here, show IP EIGRP interface details. But it's unfortunately it's not supported by packet tracer, because we want to know what we did so far with our configuration. So the benefits of summarizing routes is that summarization can be used to limit the number of routing advertisement and the size of routing tables. When we set EIGRP timers, it's important to make the hold time value equal or greater than the hello interval, because if the hold time is less than the hello interval, the neighbor adjacency will go down. The hold time will down the link before a hello message arrives. And it is important to configure authentication for EIGRP for security reasons. So this is, I tried to do this lab with whatever packet tracer allow us to do, but thankfully I went over the commands, even though they are not supported by packet tracer, but I hope you have an idea. If you have any questions about this lab, please let me know, write me, and I will answer you as soon as I can. Thank you so much for watching. Sorry because this lab was a little bit long, and I'll see you in my next video. Have a nice day.